Hey, I appreciate the question that you posted about the Arduino and how to do a timer. So as I understand it, you have a reed switch that is going to be on a drawer, I assume with a magnet next to it. So when the drawer opens, that will open up the reed switch. When the drawer closes, that'll put the magnet close to the reed switch and we'll close it. And whenever the drawer is open longer than X minutes, you want to set off a buzzer, which means we need to start a timer once the reed switch opens, and after a certain amount of time has passed, turn on a buzzer. And when the reed switch closes, turn off the buzzer and reset everything so it's ready to go for next time. So I have set up the circuit on my Arduino and breadboard to be able to play around with, and I've written a program that provides all that functionality that I will walk through and show you how I did it. I understand looking that you've found a solution for yourself, but I always find that even personally, I love to see how other people solve the same problem as I have. So thought maybe you would appreciate or get something out of seeing how I solved the problem. So here's the circuit that I have set up on my Arduino. I have the reed switch right here. My reed switch is going between port 2 on the Arduino and ground. And I have a buzzer set up, which is going between port 13 and ground. And then next to my reed switch, here's a little stack of magnets that I can pull away to open the switch, which is simulating when the drawer is open, and when the magnet is next to the switch, it closes the reed switch, and that simulates that the drawer is closed. And from a wiring perspective, you can see this wire is just jumping from port 2 over to this side of the reed switch. On this side, I have this wire is jumping over to my blue wire, which goes to ground. Red wire is port 13 going to the buzzer. So these two wires here both are ground. I'm just linking them together in series. So now let's switch to the code. So I'm going to start with demoing the program, and then I will walk through how I wrote the program, providing some of the thought and logic that I applied as I went through trying to solve this problem. I'm going to hit the reset button on my Arduino, which we can see here. I've got it. I'm using the serial output and the serial monitor to be able to show what's going on in the program. So I always like to start off with telling me the program started. We can see that the switch open is false, which tells us the switch is closed, and our buzzer is off. And that is because the magnet is next to the reed switch. If I go over and pull the magnet away from the reed switch, we can see that we write out that the switch opened to true. We get a line here that says the switch just opened, and then we see a start timer, and now we see our timer is counting up in seconds. And I've got my program set right now for the buzzer to go off after 1 minute or 60 seconds. Okay, so now we see the buzzer turned on and we can clearly hear the buzzer. So I'm going to move the magnets next to the reed switch. So now that I've placed the magnets next to the reed switch, we can see that the switch open returned false. We get this line that says our switch just closed, and we can see we just turned the buzzer off. If I pull the magnets away again, we can see that it starts over again, and we see that we got our switch just opened and we started our timer. We can close this reed switch even before the timer goes off, and we'll see it goes back to switch just closed and turns the buzzer off even though the buzzer wasn't on, but just good practice to make sure it's off. So that's how the program functions. So now let's jump into the code and I'll show you how I built this application. Okay, starting from an empty program, we have our setup function and our loop function. So in our setup function, we're going to initialize our serial ports, and I always like to start out by printing something at the very beginning, just so I have a clear indicator in my serial console that the program started or the Arduino powered on. We're going to set up our pin mode for our reed switch to be an input with pull-up resistor, and we're setting up our buzzer to be on pin that's on. We're setting up our reed switch to be on pin 2 as an input with a pull-up resistor enabled, and we're setting up our buzzer on pin 13 as an output. So the first thing I want to do is put in some code to be able to detect when the state of the reed switch changes. So when it comes, when it opens or when it closes. So I think through this, the first thing I'm going to do is I want to write myself a function that is going to be, so I want to test the switch state. And I want to do this as a separate function just so that it makes my code a little easier to read and maintain. So if I go down here and I'm going to create this new function, and first thing I want to do is actually read the digital pin and check the state of the switch. Now for the switch open variable, I want to declare it actually at the top of my program because I want to be able to use the value of this variable outside of this function, and to be able to access this variable inside the loop function or other functions, it needs to be declared at the top of my program. But now that I have that, every time I run through this program, every time I call this and the switch is closed, every time it's going to say, it's going to be setting the switch is open to false, to false, to false. But I actually just want to know when the value changed, not that every time the value gets set. And so the easy way to do that is to keep track of what the last value was that we read and check the current value against the last value. So if I, again, at the top here, if I create myself a variable that is switch last state, which we'll just initialize it to be the same as the state at the very beginning of the program, I'm going to now be able to down here add an if statement that says if the value of switch open is different from switch last state, then that means for me is at this point in time when I called this function, the actual state of the switch changed right then. So something happened. First thing I want to do is capture that state and set my last state to be the current state. So the next time I come back in this function, I will know if something changed or not by capturing that last state. And we're going to act upon that. So I want to say if the switch opened equals true, which means that the switch just opened, that's the magnet just moved away from it, which means the drawer just opened. I want to write out to the console, again to make it easy to debug my program, to say the switch opened true. And otherwise, I'm going to put in here an else that's going to be switch open false. And if we simply just leave this code in place, build it, send it over to Arduino, go back to our console here, we'll reset one more time. So now we see a program start and we see switch open. And even though we keep going through that loop multiple times, see I'm only getting one output here that says false. If I had not put this if logic in here, then instead put a print line right here, I'd be getting the print lines constantly. And in fact, let's just go ahead and let's take out that if statement and we can see the difference of what I'm referring to. So see how now my window is just filled with these switch open false. And with just that much noise in the window, it just kind of becomes useless. So that's why it's very handy to have in this if statement to be able to check the last status. So that way we're only getting something written to our window when actually something changes. So now we see program started up. We see the switch is currently false. If I reach over here and I move my magnet away, I get switch open. I put my magnet back, it's false. Pull it away, it's true. Put it back, it's false. So now I've got a very clean way just to know exactly when that switch changed, or in this case, when the drawer opened or closed. So based off that, I want to take some action. So let's start with, if the switch is opened, let's call a new function called onSwitchOpen, and then onSwitchOpen. So when onSwitch is open, I'm going to call this onSwitchedOpen function. And the first thing I would do in this is write out my switch just opened. So then again, we've got some visibility to make it easier for a debug. And according to our requirements, when the switch opens or the drawer opens, what we want to do is start a timer. So I'm going to put another function call in here, action. It says start my timer. So now we need to go write our start timer function. So to start our timer, again, going to give myself some feedback so I know what action is going on. And this is where, so an Arduino doesn't actually have a real-time clock or any sort of real clock inside of it. All the Arduino can do is keep track of milliseconds based off the CPU cycles. And so the millis function is what returns the current number of milliseconds since the Arduino was powered on. And the way we can keep track of a timer is if we capture the number of milliseconds at the time we start the timer, then later on we can compare the current number of milliseconds with the milliseconds we captured here and subtract them, and that tells us how many milliseconds has passed, which in essence gives us our timer. And again, so for this timer, I want to, since I want to use it outside of this function, I do need to declare it up at the top of our program. And here too, it's important to point out that you'll notice this timer is using an unsigned long. If we used an int here, we would actually run into problems because the number of milliseconds that can be returned by millis can be a number that's larger than what can be held in an int, and that will introduce a bug into the code. So here, make sure we're using unsigned long. And then I'm also going to have this seconds timer, and again, this is more of a convenience thing, so that as you saw in the output when I was counting up the seconds, like 1 second, 2 second, 3 second, 4 second, this is the variable I'm using to keep track of those seconds. Because again, remember, this timer is actually keeping track of the number of milliseconds. And now that we've started our timer, that's good. We've got our switch open. We started our timer, which for us, starting our timer was just initializing some variables. So now the question is, well, where really is the timer in our code? Well, for that, we need to go back up to our loop. So back at our loop, what I want to do is each time through the loop, I want to actually call a method called checker timer, which is what's going to have the logic in it to say, have the number of milliseconds passed that we expect before we can turn on the buzzer. But I don't want this method just to be called every time through the loop. I want to put some logic from it. So first thing is, we only need to call it if the switch, or i.e. the drawer, is actually open. Also, I'm adding in here too, I only want to call it if I haven't turned the buzzer on yet, because after I've turned on the buzzer, there's no point in using a timer anymore. But we have not declared this buzzer on variable yet. So we're going to create that now and put that here at the top of our application. So we're going to create buzzer on and have it initialized to false when our program first starts up. And it's for good practice, since we set this pin mode to output, let's go ahead and set that pin to a known state at the time when we start up our program. In this case, we're going to set it to low, which ensures that the buzzer is turned off. So now we're saying if the switch is open and our buzzer is off, we want to check timer. So this is another function that we need to write and add. Here at the bottom, I add the check timer function. So when the check timer function gets called, it's going to call millis, which gets the current number of milliseconds since the Android powered on. We're going to subtract from it the number of milliseconds we captured when we called the start timer function, and take that delta, divide it by 1,000 so that we can convert this into seconds. And then that tells us current seconds, which is the number of seconds that have passed since we called our start timer function. If the number of current seconds does not equal seconds timer, then that means a second has gone by or has ticked up. And then that's when we want to set our seconds timer equal to current seconds. We're going to print out our seconds timer. And here we're going to check, so okay, seconds timer greater than time limit in seconds, which is a new variable that we need to declare. So let's go add that to our program. So here at the top, I'm going to declare time limits in seconds. And this is the total number of seconds that we want to pass before we turn the buzzer on when the drawer opens. And I write it out this way because just make it a little bit more easier to read, because if you actually want to say, I want the timer to be 2 minutes, well, again, keep in mind, we're tracking it in seconds, so I could have written here, 2 minutes is 120 seconds, but if I come back and read my code and I look at 120, I'm like, well, what does 120 mean? But if I do this as 2 times 60, the Arduino, when it compiles, does the math and converts that to 120 for us. So it's still going to use the number 120, but now my code's a little more readable, because now I can say, oh, what I'm really going for here is 2 minutes. And it's easier to see that way. But for testing, I don't want to have to wait 2 minutes, so I'm just going to leave it as 1 minute to make that easier to debug. So now down here, we're going to say when our number of seconds exceeds the time of seconds, we're going to output that, hey, we're going to turn the buzzer on. We're going to set our flag that the buzzer is on, and then we're going to turn on that digital pin 2 to have the buzzer go high. And by setting this buzzer on, if you remember now in our loop, the next time it goes through the loop, it says our switch is open is true, but buzzer on is true as well. So it will no longer call the check timer, which makes the code a little bit more efficient. Now it's still going to keep calling the test switch state. So if we go down to test switch state and then we close the drawer, now our switch is closed. That's going to say, is switch equal true? Nope, it equals false. So we're going to go to this else statement. So now at this point, we need to call a function and say, hey, the switch just closed. So we can add our function call in here for on switch closed. We can go down here and add our on switch closed function, which again, let's output to the serial console that, hey, the switch just closed. And let's go ahead and turn the buzzer off. And like I said, we could add an if statement here that says only turn it off if it was on, but again, it doesn't make a big difference. We'll just turn it off. And that is the full logic of the program. Now, while breaking it up like this into functions allows you to, if you add additional requirements and say you want to do, for example, when you turn the switch on, in addition to starting the timer, say here you wanted to also turn on an LED, you'd be very easy to find in your code where to add that logic, because you can say, oh, whenever the switch is opened, I want to turn on that LED. And this makes your code much more easier and modular to maintain and make changes to it. Compile this, send it over to our Arduino. And here we go. We can see our program started. Our switch open was false, so the switch just closed. And when I said buzzer's turned off, I'm going to reach over and remove the magnets away from the switch. And there we go. We can see that our switch just opened, so we started our timer. If I put the magnet back, we can see switch just closed, and means that we're no longer making the call to the timer, which in essence stops the timer. And then we turned the buzzer off just in case it was on. So there you go. I hope you find this helpful and useful. Appreciate any feedback you have.